Hi everybody, my name is Mrs. DeVille and I'm a 4th and 5th grade math teacher at Euclid Park Elementary in Cleveland. And today I'm here to do a little math
Hey Mom,
lesson.
I'm hungry.
Well, I guess it is time to start thinking about lunch maybe. Let's see, what should we have today?
Mom, can we order from Dairy Queen for lunch?
Dairy Queen. That's a good idea. I have lots of choices. And I believe right now they're doing DoorDash so we can have no contact delivery. That would be perfect for this time. All right, okay, Dairy Queen. So I'm gonna go get the menu and you go get some paper and pencil so that you can help me write out these problems. I'll give you just a minute, paper and pencil. All right, hopefully you had enough time to get your supplies. This is gonna be my paper and my pencil. All right, so in my family we have 5 people. And so I'm gonna write down the orders for the 5 people on my chart here, and I want you to do the same thing on your paper. So let's see, Danielle likes to order the flamethrower chicken wrap. So I'm gonna put a capital D for Danielle, and I'm gonna put the price of the flamethrower chicken wrap, which is $1.89. So we're gonna write down $1.89. All right, you're following along. Okay, then Camille and Grace and I, we all like the double cheeseburger. So we're gonna all order the same thing, but I'm gonna list them under our names. So we had Camille, Grace, and Mom. And our double cheeseburger is $2.89. So go ahead and write $2.89 in each of the next 3 columns. And then my husband, he likes the, what was that thing called? The crispy chicken sandwich. So for Dad, the crispy chicken sandwich is $3.79. So that's everybody's sandwich. Are you up to date? You keeping up with me? It's gonna be important. We're gonna have lots of numbers here. Okay, so then let's see. Well, of course, they're all gonna want fries because what else do you have with a sandwich but fries? So small fry is $1.79. So we're gonna give $1.79 to everybody but me because I'm not much of a fry person. I'm going to do something else, but let's go ahead and put $1.79 under everybody but me. And I am gonna be healthy and get the garden salad, which is, where is that? Under the sides, $1.89. So that gives everybody a sandwich and a side dish. I think that looks pretty good. All right. So I'm wondering how much that is, like around how much that is, because, you know, we got to kind of watch the budget these days. So if I'm trying to figure out around how much this costs without actually adding all these digits together, what can I do? Yes, I can estimate. I can estimate by rounding these numbers. So we're gonna round each of these prices to the nearest whole number, and then we can add them together and get a better estimate. So if I have $1.89, is that, if we are rounding to the nearest whole number, to the number in the ones place, is that gonna be closer to $1 or $2? Yes, it's closer to $2 because it's only 11 cents away. So I'm gonna put a 2 in parentheses here $2.89, is that closer to $2 or is that closer to $3? You're right, it's closer to $3 because it is, again, only 11 cents away from $3. So I'm gonna mark that off as $3, and of course, the other two that are next to it, kind of small, sorry about that. And then finally, $3.79, we're gonna round that to $3 or $4? $4, because again, it is over $3.50, but under $4. So we're gonna round that to $4. And then our fries for $1.79, I think you're starting to see a pattern here. That again, closer to $2 than it is to $1. It's over 1.5. So we're gonna make each of these $2. And even the $1.89, because that follows the same pattern. I'll give you just a minute to get caught up on your paper because I know I always write quickly. And so we have the estimates of all of our items. So now we're going to add those together, but let's see if we can add them together mentally rather than just, adding on each time. Maybe there's a better strategy. Maybe there's a better pattern that we can use. So I'm looking at my numbers in purple, and I see that we have a lot of 4s and quite a few 3s. So let's combine, I have a lot of 2s and quite a few 3s. Only 1 4. So let's go ahead and combine those 2s and 3s and then put it all together. So I have 1, 2, 3, 4, 5, 6 2s. So I know that 6 2s is the same as 6 times 2. 6 times 2 equals 12. All right, and then our 3s, I have 1, 2, 3, 12, 3 3s. 3 times 3 equals 9. 6 plus 9, 12 plus 9 equals 21 plus 4 equals 25. So our estimate here of how much all of this is going to cost is approximately $25. $25. All right, that's a lot, but it's worth it. It's good food. So I think we'll go ahead with that.
Mom, can we get ice cream too?
Oh my goodness. Well, it is Dairy Queen, and who's going to Dairy Queen and not getting ice cream? That wouldn't make very much sense. All right, let's check our menu here. We can't get a cone. That wouldn't be very good for delivery, so I guess we'll go with the sundaes, but they're going to be small sundaes because this is only lunch. So $2.29 for a sundae. We'll decide on the flavors later. So I'm gonna add in another $2.29 for each of us because nobody wants to be left out. We are really a ice cream loving family, and if I left anybody out, they would be extremely upset with me. So what does that do to our total? What does that do to our estimate? Well, $2.29, again, is that going to round to $2 or is that going to round to $3? In this case, we are below a half at 29 cents. Half of $1 is 50. So this would be closer to $2. So we're going to round to $2, and we're going to do that for each one of these. And again, we had 5 people, so that's 5 sundaes at $2 each. Approximately 2 times 5 would be an additional $10, or 2, 4, 6, 8, 10. So an additional $10 on our estimate brings our estimate total to $35. All right, so $35 for lunch. That's not too bad. I think we can handle that. So Now, if I want to find out exactly how much this is going to cost, though, that was an estimate to make sure that I had, approximately the right amount of money, but I need to know exactly how much I need to pay for this food. So that means that I need the actual amount. So if we're going to calculate the actual amount, we're going to add, as we kind of have been doing, but this time we're going to use the real prices. Now, when I go through these, I'm looking at my numbers and I definitely see some repetition. So if I start with my first one, $1.89, and I'm looking through, I have another $1.89 here. So if I put those together, I can add $1.89 plus $1.89, or I can do what? Multiply. I can multiply $1.89 by 2. So for the 3rd and 4th graders who are watching today, you're going to go ahead and add those numbers, making sure that you line up your decimal point, meaning you keep the ones under the ones and the tenths with the tenths and the hundredths with the hundredths. But 5th graders, we're going to multiply because we know that's quicker and more efficient. So we are going to, as a reminder, I'm going to help you with the first one, but upcoming you're going to be doing some more on your own. So $1.89 times 2. So we remember, and we have been multiplying basically all year long, so we know that we can now do the shortcut method. If you know a different method, you can go ahead and use that. If you're using the area model or expanded notation model, you can do that, but we're going to use the shortcut method because we're at the end of the year and we're ready for that. 2 times 9 equals 18. We're going to put down our 8. We're going to carry our 1. 2 times 8 equals 16, plus 1 more is 17. Carry our 1. 2 times 1 equals 2, plus the 1 is 3. That gives us a grand total of $3.78. If you did addition instead, your problem should have looked something like this. $1.89 plus $1.89 equals $3.78. And of course, carrying our ones just like we did with our multiplication. So then we're going to go to our next item, which is the $2.89. And we have 1, 2, 3 of those. So we're going to, again, either add $2.89 3 times, or we're going to multiply $2.89 times 3. I hope you have written that down on your paper. I'll give you a second to get started. 3 times 9 equals 27. We're going to put down the 7, carry the 2. 3 times 8, 24, plus 2, 26. Carry the 2. 3 times 2 equals 6, plus 2 equals 8, bringing our total to $8.67. Now again, if you are using repeated addition, which is fine, then you should have something that looks like this. Notice that I added all 3 in a row, but you could add the first 2 and then add 1 more, and that would work also, if that is easier. But again, making sure that we line up our place values. If you don't do that, you're going to get the wrong answer. And we don't want wrong answers, especially when we're talking about money. Alrighty, then we move to, $3.79. Do I have any other $3.79? We don't. So we're going to leave that separate for right now, and let's go to our fries, our $1.79. So there's 1, 2, 3, 4 $1.79. So let's write it. $1.79 times we said we had 4 fries, so there were 4 of them. I'm going to give you just a minute to get started on this before we go through and write our answer. So if you multiplied this correctly, you should have gotten an answer of $7.16. Is that what you got? I hope so. For those of you who added, I did mine this way. You might have done a different method. So you can see that I added $1.79 plus $1.79 gave me $3.58. And then I knew that I had 2 more $1.79s, so I've already added that, so I added $3.58 plus $3.58, and that gave me the $7.16. You might have done something else. You might have lined up all 4 numbers and added them that way. You still need to end up with $7.16, and if you didn't, you need to check your work. So great, we are moving along. I think the only thing we have left is the ice cream sundaes. So let's go ahead, and we knew everybody had an ice cream sundae, so there are 5 of them, but I'm going to circle them just so we know that we have taken everything into consideration. And we have $2.29, and we had 5 of them. So we are now going to do $2.29 times 5, or $2.29 plus $2.29 plus $2.29 plus $2.29 plus $2.29. So take just a moment to calculate your answer. So I'm going to go ahead and talk through this one. 5 times 9 is 45. We put down that 5, carry the 4. 5 times 2 is 10, plus 4 is 14. I put down my 4, carry my 1. 5 times 2 is 10, plus 1 is 11. And put in that decimal point 2 places in our factors, 2 places in our product. And again, if you know a different method of multiplication, you can still solve this problem the same way. So if we made our area model, our answer would be the same. We would just have to still go back and put that decimal point in. So now have we taken all of our items into consideration? All except for the chicken sandwich. So in addition to all of these numbers, we have the $3.79. Now what was our original goal here? What were we trying to do? What were we trying to solve? We wanted to come up with our grand total. So let's go ahead and add all of these parts together, and let's get it set up first. So we have $3.79 plus $3.78 plus $8.67 plus $7.16 plus the $11.45. And again, notice as I'm doing this that I am making sure that all my tenths are lined up. All my hundredths are lined up, all my tenths are lined up, all my ones, and of course my 1/10. Very important. If it's too much for you to add this way, take 2, and then 2, and the last one, and add them all together. But we're gonna go ahead and add this in a vertical line because We can. So 9 plus 8 is 17. 17 plus 7, 24. 24 plus 6, 30. 30 plus 5, 35. Put our 5, carry our 3, and let's go ahead. 3 plus 7 is 10, plus 7, 16, 17. 10 plus 7 is 17. 17 plus 6, 23, plus 1, 24, plus 4, 28. Put down our 8, carry our 2, we're almost done. 2 plus 3 is 5. 5 plus 3, 8. 8 plus 8, 16. 16 plus 7, well, 6 plus 7 is 13, so that's 23. Plus 1 is 24. Put down our 4, carry our 2. 2 plus 1 is 3. Decimal point stays in line right where it was. $34.85 would be our total cost for this meal. What was our estimate? $35. We were very, very close. We were only 15 cents off of our estimate. So we did a really good job with that estimate and around what we're gonna have to pay. So we're looking pretty good. We're almost done. But I found a coupon. I found a coupon. And the coupon was $1 off every sandwich that you order. We ordered 5 sandwiches. So for our estimate, we are going to be able to take off $5. 35 minus 5, that's an easy one, would be around $30. But again, I want to know exactly how much it's going to cost. So let's take our $34.85 and subtract the $5. So I'm going to give you a minute to do that, to work that out. Okay, so let's go ahead and subtract. 5 minus 0 is 5. 8 minus 0 is 8. 4 minus 5. Can we do that? Well, no, not really, but we know that we have 34 minus 5, so that definitely can be done. So we are going to regroup. We're going to borrow from this 30, take 10 away and make that 20, and we're going to give the 10 to the 4 and make that 14. So this is 20 plus 14, which is still 34. We've just changed the way that we've structured this. 14 minus 5 is 9, and 2 minus 0 is 2. Again, very close to our estimate. This means that we owe the restaurant $29.85. I owe the restaurant because I'm paying the bill. So, all right, so that's pretty good. I think we're almost ready to place our order. The only thing we have left is that we said we were going to get this through DoorDash. DoorDash has free delivery right now, but we do have to tip our driver. So our driver, I want to be generous, so I'm going to tip our driver 20%. So we need to figure out 20% of the $29.85. Now, that's 15 cents away from 30, so since I want to do this mentally, I'm going to round this up to $30. We want 20% of $30. How do we figure that out? Well, 10% of $30 would be 1/10 of 30, or 30 divided by 10, which is $3. And if you remember, We learned an easier way to take 10% of 30 by just moving our decimal point one place to the left. That'll be $3. But we want, that's 10%, we want 20%, so we need to double that amount. $3 plus another $3 is gonna give us $6. So a 20% tip of $6 is gonna go to our driver because we know that times are tough right now and we need to help those around us. So that is kind of the least that we can do. So I think we're all set. I know that I need about $30 for my food. I need $6 for my tip. I think we'll be ready to order our lunch. And I really appreciate your help today. I hope that you can see that this is something that you can do at home on your own anytime. The menus I looked up online, but you can also just make up prices and figure out what the cost would be for your family to order some food. We did a variety of mathematical concepts here. We covered decimal, we did rounding and estimation. We did decimal addition, subtraction, multiplication, and then we came to do some percents. I hope that you will find some activities around your home that will keep your brain engaged, keep your family motivated, and have a good time together. Thank you for joining me today. I hope to see you again soon. Bye-bye.
I'm Jordan Sigler. I'm a 4th grade teacher at Halley School here in Cleveland.
I'm Crystal Urbanski. I'm a 3rd grade teacher at Halley School in Cleveland.
And we're here to do a little science. So our challenge today is going to be, can we make the ultimate paper airplane? So we're going to test 4 basic models. But what I want you to do is, using the things you learned today about how airplanes fly, use that knowledge to build an even better plane. So right here is a styrofoam plane, and it's very, very light. Obviously heavier than paper, but still really light. And we're just going to use this one to do a few test flights just to see how it flies through the air and see if we can notice the different forces working upon it. It's pretty windy, so I'm not sure how this is going to go. This science activity can be done at home, and all you need is some notebook paper and a pencil. Or you could also use a pen, or really any kind of paper will work. When I was a kid, I thought that planes must fly because they have that big rocket on them. And now that I'm older, I realize that can't be true because bees can fly and they're not attached to a rocket. And paper airplanes fly, but they're not attached to a rocket either. So that got me wondering, how do planes fly? Aerodynamics. Aerodynamics is the study of how things move through the air, like birds and planes. The word aerodynamics is easy to remember because the first part of it starts with aero, which is a Greek prefix that means having to do with the air.
Instead of planes flying by magic or rockets, planes actually fly using the 4 aerodynamic forces, one of which you see here, weight. A force is just a push or a pull. So when we're thinking about the 4 forces, weight is the force that's pulling the plane or the object flying down to the ground. This is actually caused by a force that we all know very well, gravity.
As you design your ultimate paper airplane, you want to think about how weight is going to affect the flight of your paper airplane. If you use paper that's too heavy or you add too many things to your paper airplane, the weight could pull your plane down to earth.
Lift is another one of the 4 forces, and it's the one that holds the plane in the air. It's the opposite of weight. Lift is caused when the air below the airplane's wing is pushing up harder than the air above it is pushing down. This is the difference in air pressure. Thrust is another one of the 4 forces, and it's the forward movement of the plane. And it's interesting because in a normal airplane, you would get this from your engine. But for paper airplanes, it's a little different because you give your plane its thrust. And you don't give it continual thrust. It doesn't have thrust the entire time like a jet engine would. Instead, you give your paper airplane one big burst of thrust. Then your plane just glides through the air. Drag is the last of the forces you need to know about in order to build the ultimate paper airplane. And drag is exactly what it sounds like. Drag is the paper airplane's resistance when it flies through the air. A good way to get an example of this is if you take your hand, like you're about to give somebody a high five, and wave it through the air like crazy. You'll feel a lot of drag or air resistance. The way you build your plane will be very important in eliminating as much drag as possible so you get the most distance out of your plane.
Here's how to make the first basic plane. First, you're going to take your piece of paper and fold it in half long ways, or hot dog style. Make sure you crease it really well everywhere you fold. Open it back up and take the corner and fold the point and the whole side down into the middle. Make sure you're taking and folding it in right down to the middle so it matches up. Do the same thing to the other side. Once that's done, we're going to go ahead and fold it right in half along the crease, or the middle fold. Make sure you crease all the edges again, and then we're going to fold the wing down to the bottom of the plane, nice and straight. Give it a good crease. Go ahead and we're going to flip it over, and we're going to do the exact same thing on the other side, making sure that we make it nice and straight and that the wing touches the bottom of the plane all the way across. Give it a good crease, and you should have a nice basic plane. This plane is the most common plane that people learn how to make, and it's very useful. It gets good distance and spends a good time aloft or in the air. So now we're going to make the basic dart plane. This is similar to the last plane we made. We're going to fold it hot dog style to begin, and make sure we crease really well on the sides, then open it back up. And now we're going to take the corner in just like our basic plane, meet it in the middle, and crease it really well. We're going to do the same thing on the opposite side so that the two folds match up. You should see a nice big triangle at the top now. Once we're done with that, we're going to very carefully fold in that side of the triangle to the middle. And we're going to do the same thing on the other side. So you should now see this shape when you folded it. Now we're going to fold this in half so that all our folds are inside. And to make the wing for this one, we're going to actually fold from the long side right there. We're going to fold it down to match up with the bottom. So this plane is going to be very pointy. And we're going to crease it really well for this side of the wing. And we're going to flip it over And again, do the exact same thing on this side. Again, creasing very well and making sure it matches up with the bottom. This is going to make a nice pointy plane, and it's called a basic dart. This plane is called the Buzz, and we're going to do the same thing as for our two basic planes. We're going to fold it in half, hot dog style, and crease it really well on the side. Then when we open it back up, we're going to go ahead and take the corner, fold it in of the top right side, and do the same thing matching on the opposite side. Once we've done that, here's where the directions get a little different. This time, instead of folding it in half and making wings, we're going to fold these two flaps down right where they meet the edge of the paper, right where their edges meet, and we're going to fold it straight down and crease it really well. So you should have more of a square shape now than a rectangle. Kind of looks like a giant envelope. Now we're going to take the corner, and about an inch above the tip of that triangle we push down, we're going to crease it, and we're going to do the same thing on the other side. So the point should meet in the middle along the crease, and you should see a little diamond shape right in the middle. Now we're going to fold that up, and that's going to kind of hold those two pieces in place while we do our next folds. Make sure you crease it really well. For the next step, what we're going to do is we're going to take it, and we're actually going to fold it in half so that our folds are all visible on the outside of the plane. Make sure you crease it really well if you see anything falling apart or acting crazy. And now we're going to make the wings. This is a little bit harder to make the wings on because the paper is so thick. So we're going to carefully fold right about there on the plane and crease it really well. You can use a pencil, a pair of scissors, anything with a hard edge to help you crease if you're having difficulty getting it creased enough.
And now you have your Buzz plane, and when you feel this one and look at it closely, you can tell that it's a lot different than the other two planes, and it's a lot heavier in front. So it'll be interesting to see how far this one goes.
This last plane is called the Stable, and we're going to actually have the paper this way. We're going to fold it hamburger style in half and crease it really well. And when we open it back up, we're going to do the same step as a lot of the other planes, where we're going to take the corner and meet it in the middle. Crease it really well, very important on this plane. And go ahead and do the same thing to the opposite side. And crease it really well on that side. So the next step for this plane is we're going to go ahead and take the tip of our big triangle right here, and we're going to fold it right to where the two corners that we folded in meet. So it should look just like this. Then we're going to take the upper corner and we're going to fold it in so that that whole side meets in the middle nice and straight. Make sure it's creased down really well. And then we can do the same thing on the other side. Now the next part is to take it and fold it in half and make sure it's creased really well. So feel all your edges, make sure they're all creased, and you should be able to open it up and see the wings and the bottom of the plane, and it should look just like this.
Now that you have some awesome planes to test out, it's time to make a prediction. Making a prediction in science is a lot like making one while reading a story. In a story, you'll use information and observations to predict what will happen next. Based on your observations, which plane do you think will fly the farthest? Why? Well, to see whether your prediction is correct or not, it's time to test out your planes. To do that first, we need a couple things so we can write down the data we get from testing each plane. The first thing we're going to do is make an easy data table. A data table is just a chart where you can record your data. It could be tally marks, it could be measurements, it could be numbers. Let's draw our box first. So I'm gonna make this one 5 lines long. And now I have a nice neat little box. I'm gonna make a line first up here. This is where the labels for each of my columns are gonna go. Here's where I'm gonna label each airplane. Here's where I'm going to do trial 1. That's the first test I'm gonna fly with each airplane. And here, I'm sure you can guess, trial number 2. And finally, in my teeny tiny box, trial number 3. The next part's making a bar graph, and as you can see here, my first graph didn't go so well, but don't give up if your first one gets messed up. The first part to a really good looking graph is a nice title. So I'm just going to call this something simple. I hope you'll be more creative. I'm going to call it Airplane Bar Graph. Yes, I know, very boring. And now for the hard part. I'm going to make this 10 lines long, just to make it nice and even. And make this into a nice box. It'd be prettier if I was using a ruler, but if you don't have a ruler at home, you can also use the side of a hardback book. Now that I have a nice square for my graph, I'm going to go ahead and label everything. If you see right here, I labeled this side steps and I labeled the bottom part of the graph 0. That's because I don't have a measuring tape here. So I'm gonna need a different way to measure something on how far my airplane traveled. So the 0 steps is just me stepping 1 step at a time to my plane. And that's an easy way to do it at your house as well. Here on the bottom are going to be the names or types of the different airplanes. I'm gonna label that. And now I'll write each airplane's name in. So here's the basic, the dart, the buzz, and the stable. All 4 planes. Notice right here, I haven't labeled all the number of steps in my graph yet. That's because I don't know for sure if my planes are gonna go really far and I'll need to label it maybe by 10s, like 0, 10, 20, 30, 40, or if I'll need to do it by 1s or 2s, 2, 4, 6, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're gonna be extra awesome, you could always make this whole thing bigger and add even more planes that you wanna try out. Another thing you can do is draw a diagram of the airplanes that you've made so far. A way to do that is just draw a simple drawing of one of your airplanes or more. Here's my attempt. And then a diagram has labels so that people looking at your information understand what you're talking about, and it helps them understand the project as a whole. So I'm going to label mine the basic dart so people know what kind it is. And now I'm finally ready to test out my plane, so I'm going to fill out my table and start recording my data.
So, for some reason, it is snowing, and it's April, but we're still gonna test these planes somewhere out here. Hopefully when you do this, it does not snow.
Now that you're finished with testing out your plane, hopefully you filled in your whole data table so that you have all the information needed to create your graph. And once you have your graph all done, then you can really start thinking, what about my paper airplanes worked really well? What did I notice made them fly farther or faster or do tricks? And how can I replicate that and make the best paper airplane, the ultimate one? Here's some tips and tricks to make the ultimate airplane design. So here I have the basic model. I just built the first one we made, and I want to show you how to make there be a little bit more weight in the nose of the plane. So what you'll see I did is I just folded in the tip of the plane and then refolded the wings, and now the tip of my plane is a little bit different, so it'll fly different. There's two things that are on a plane that are not on a normal paper airplane, and that's the rudder and the landing gear. So here you see a normal plane, and on the bottom you can see that the wheels are sticking out. That's its landing gear. In the rear of the plane you can see what's called the rudder. Now normal paper airplanes don't have this, but there's no reason with a little tape that you couldn't try to add both of these things and see what happens. Another cool thing you can make at home is a helicopter, and it uses the same forces as a plane. And it's very, very easy to build them. You can use everything you still have at home. You can use paper. I'm going to use an index card and show you how to make one. And if you have a paper clip, that'd be helpful too, but again, not necessary. So here I have a marker, a pen works, pencil works, and all I'm going to do is draw a line straight down the middle of the paper. You can use a ruler or something to help you make it a little bit easier. And straight, don't look at my line, it's a little bit curvy. And go ahead and make another mark down the middle, the other direction. So you have a little, almost like a giant plus sign right there. Go ahead and divide the bottom into 2 parts. And now we're gonna do some cutting. So first what we're gonna cut is this side right here. This is kind of gonna be the bottom of our helicopter. And make sure you cut carefully, because if you cut it wrong, like I did 15 times, you're gonna use a lot of paper. And cut that side. And now, very carefully, we're gonna cut straight down the middle to this horizontal line right here. And then we're gonna fold the 2 helicopter rotors opposite directions, because that's what's gonna make the helicopter spin. Once you've got that, we're going to work on the bottom. So all you need to do for the bottom is make it a little bit heavier so that it'll be pulled down by gravity and help the rotors spin. Another thing that could help you make the ultimate paper airplane is a thing called elevators. Elevators are on real planes, not just paper airplanes, and they help with lift on a plane. I won't tell you how. See for yourself. Here's how you can make your own elevators on just the basic model. So I have the basic model here, and the elevators are on the back of the paper airplane. So you just want to mark off a place on the back to kind of cut into the plane and make a little flap that you could fold up or down. There's a million different ways you can do it. You can look on ways online, or you can just try it out yourself. Fold up different parts of your paper airplane in the back wing and see how it helps or does not help your paper airplane. You also want to try to make sure they're exactly the same on both sides. And after you get that down good, go ahead and try putting one up and one down and see what happens. Another thing you can try is taking your wings and just making small adjustments to them. For instance, this is the basic plane model, and I'm just going to take the edge of the wing and fold it down like this. there's lots of different things you can do to your plane to make them fly differently. You could also, instead of folding them down, you could try to fold them up and then fly it a few times and see what happens. Does it make it fly farther? Does it make it do loops? Just go for the ultimate plane. Before we go, I'm gonna give you a quick overview of all the different parts of an airplane in case you get any ideas about how to make your paper airplane even better. So here's an airplane. And one thing I want you to notice is that not all airplanes are the same. This is an airplane with propellers, and you've probably seen a lot that have no propellers, but I wanted to show you this kind so you'd know what a propeller looked like. So first we have the fuselage. Now the fuselage is the body of the plane, and it holds everything together, and it even carries the fuel for the plane. Right over here is the cockpit of the plane, and that's where the pilots are, and where they can control and steer the plane and communicate with other planes and ground control. Over here are the engines. Now these are have propellers on them, but often you see ones that just have the turbines or a jet engine. And of course, last but not least, we have the wings. And the wings help generate the lift for the whole plane. Next we have the horizontal stabilizer, and that's this part of the plane right here, and this controls the pitch of the plane. Over here is the vertical stabilizer, and that controls the yaw of the plane. This middle part right here, the back flap of it, can go back and forth, and that's called the rudder. And if you've read any books about boats, boats also have rudders that help them steer. Right here is the elevators, just like we made for our own planes when we cut into that back of that plane to see what would happen. And over here on the plane, you can see the flaps. And these flaps change the lift and the drag for the plane. You might also see on planes something called an aileron, and that changes the roll and can rotate the body of the entire plane. You might also see spoilers on a plane, and these will be on the wings about here, and these change the lift and the drag also, and they can also rotate the body. You can also see over here on a plane often little slats, and this helps change the lift of the plane as well. Over here is just a cabin door, and this would be how people could get in and out of the plane. There's usually more than one. And in an emergency, this can be opened up and an inflatable slide pops out so people can get safely to the ground. Although you're probably not going to have an inflatable slide on your little paper airplane. It's still good to know about and to know. Share what you've made with your teacher, or you can even email it to me at jordan.sigler@clevelandmetroschools.org so we can all see the cool stuff you've made. The world record for the longest distance paper airplane was made in 2012 by John Collins, also known as the Paper Airplane Guy. His airplane went 226 feet and 10 inches. Can you beat the record?
Hello, my name is Jason Levy, and I'm the music teacher at Campus International. I have a song that I'd like to share with you. It doesn't have very many words, so hopefully you'll be able to pick it up very quickly. Bim bum, biddy biddy bum, biddy bum, biddy biddy bum, bim bum. Bim bum biddy biddy bum biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy bum biddy biddy bum bim bum. So like I said, this song doesn't have very many words at all. 3 in fact. Bim, bum, and biddy. So this next time I'm going to sing the song, but this time I'm going to add the motions that goes with it. See if you can stay with me. Bim bum biddy biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy biddy bum bim bum. Excellent job. So just like this song doesn't have very many words, this song doesn't have very many motions either. 3. On every time we say the bim, we're going to clap our hands together. Every time we say the bum, we're going to snap our fingers together. And every time we say the biddy, we're going to pat our lap together. And if you say biddy twice, then you're going to do it 2 times in a row. So biddy, biddy. So this last time, we're going to try it together. We're going to sing the song. We're going to add the motions. And let's see if you can do all of those things together. Bim bum biddy biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy biddy bum bim bum. Bim bum biddy biddy bum biddy biddy bum bim bum. Very good. One of the things that makes this song and game a lot of fun is trying to do it faster and faster each time. So as you practice this on your own, keep trying to go a little bit faster, and we hope that you get even better at it. Again, I'm Mr. Levy from Campus International, and I hope to see you again. Thanks. Have a great day.